Welcome back, Geo students. We are actually finishing up 6.3 here. I made this in two videos because I wanted you to just stop and grab some paper. And also, this section is just mostly about doing some practice problems that, we talked about what a centroid is, what an orthocenter is, and this is just kind of doing some of the work that goes behind it. All right, so we're going to start on page 178 of your student journals. I'm actually going to do number 6 with you guys. And so the first thing I want us to do is let's read the directions. So it says, find the coordinates of the centroid of the triangle with the given vertices. So on this one, it's fairly straightforward. It tells us that we're finding the centroid. So the first thing I'm going to do is I'm going to kind of draw in my grid here. Now you can use, so for this one, I actually used the paper that they provided. But you could use a separate sheet of graph paper too, because I'm going to be off the grid here a little bit. So, bear with me. All right, so first and foremost, let's plot all these points. So -2, -1, 1, 8. So 1, 2, 3, 4, 5. So I'm going to put it about here. So again, obviously off my grid, and then 4, -1. So I'm going to draw in this triangle. So this, what they gave us is basically the 3 coordinates of your triangle. So what makes this example, this is what I would consider an easier example. What makes this example somewhat easy is the fact that, 1, 2, 3, 4. Whoops, I drew that wrong. What makes this one somewhat easy is the fact that we have our triangle. I knew that looked a little bit odd. Our triangle is, the line segments, like this line segment is a horizontal line, which ends up making this problem a lot less difficult. And I'll show you one that ups the ante a little bit and shows you a little more challenging problem. Okay, so anyway, what we're going to be doing is we're going to be finding the coordinates of the centroid. So in order for us to do this algebraically, we need to find the midpoints of 2 line segments. So what I did is we're going to find the midpoint of, probably the easiest one to find is of A to C. So this is, if you graphed it correctly, 1, 2, 3, 4, 5, 6. So the midpoint would be right here. And I'm going to call it D, just because we used A, B, and C already. All right, so next, let's go ahead and draw in our median. Okay. So what I'm going to do here is, rather than kind of draw in another median and find the coordinates of the centroid, like to figure out the midpoint of B to C, you could do it that way. I'm going to show you another way of doing it. So you could figure out the midpoint of A to B or figure out the midpoint of B to C. It's not going to necessarily line up 100%, so it tends to be a little bit more challenging in that direction. And then you could go ahead and connect your vertex to that midpoint and then locate where your centroid is. Another way of doing this is to go ahead and find one median, so the one that was easiest, right? So we just found the midpoint pretty straightforward. I'm going to now find the total distance of B to D. So I'm just going to use my distance formula and figure out the total distance of B to D. So I'm going to grab another sheet of paper. And so I'm going to do the distance of B to D. So remember, B is the point 1, 8. D is now the point, let's see here, this is 1, -1. So I'm going to figure out the distance between the two. So x2 minus, x2 minus x1 squared plus y2 minus y1 squared. So I get 0 plus, that would be 9 squared, which is 81. And so I get 9. So what I figured out is the distance from B to D is 9. And so the next thing I'm going to do is, I know the centroid is 2/3. Like, if I figured out that if this is the whole distance, I know that the centroid is located, if I start from B, it's 2/3 the distance. So I'm going to do 2/3 the distance of B to D. So I get 2/3 of 9 is 6. And so what I figured out here is that this is, so my centroid is 6 units along or down from B along this line segment. So if I counted correctly, so again, this is probably where it would be helpful if I had this on regular graph paper, but this was at 1, 8, so this is 1, 2, 3, 4, 5. So this is 3, 4, 5, 6. So if I counted down 6 spots from the point B, I know that my centroid has to be located here. Because if B to D is the median, then B to the centroid has to be 2/3 of that distance. So this distance must be 6. And so now this is my centroid. So now we can name that point as 1, 2. So my centroid, and I'll just kind of go back here, I'll say my centroid is at the point 1, 2. So again, this works out really well when you have a midpoint that's very easy to find, like a horizontal or a vertical line, and then you can just kind of count the distance. What makes it more challenging is if you don't. So that's kind of where I wanted to go next. So we're going to kind of take a side trip here. I want you to grab a piece of graph paper, if you would. And we are going to give you an example of a scenario in which you're finding the coordinates of the centroid. So put find coordinates of the centroid. But this time, we're not going to give you ones that are, I guess, as easy. So I'm going to go ahead and start by going ahead and drawing kind of my 4-quadrant graph. So I'm just going to draw. And oops. Okay. All right, so I'm going to give you 3 points. So I'm going to give you the point G, H, and F. So I'll give you the point G at the point -2, 7. Point H is at the point -6, 3. And point F is at the point 1, 5. So let's graph all of those right now. So this is point G. This is point H. And this is point F. So I'm going to go ahead and draw in my triangle. And you will notice that all of these line segments, none of them are vertical or horizontal. So what this does is when we're asked to find the distance or the coordinates of the centroid, it makes it a little bit more challenging. So I have a different strategy that we use when it comes to this type of a problem. So my strategy is to go ahead and find the equation of 2 different medians. So if I can find 2 different medians and then basically use those 2 different equations to find the intersection, so solve the system, I can figure out the coordinates of that midpoint. So my first job is to find the equation of 2 different medians. All right, so in order to do that, I need to do a little bit of work. So we're going to find, I guess, I'm going to start with finding the median from G to the midpoint of HF. So my first step, I'm going to label this as my points here. My first step is to find the midpoint of HF. And the reason I'm doing that is so I can figure out the median, right? So the midpoint of H to F is I add up the x's, divide by 2, add up the y's, and divide by 2. So I get, what is that, -5 over 2, so -2.5, and that's 8 over 2, which is 4. So -2.5, so 1, 2.5, 1, 2, 3, 4, and that looks about right. And I will call this M for midpoint. And then I'm just going to go ahead and connect that dot, to figure out my median. So now I have a median G to F, which is from the vertex to the midpoint of the opposite side. So my goal here is to find the equation of this line. So I know that this point is -5, 2, and I know this point is 4. I'm sorry, the y coordinate of that point is 4. I know this is -2, 7. So I'm basically using my, Algebra 1 skills and finding the equation of the line that passes through -2, 7 and -5/2, 4. So the first thing I'm going to do is find the slope of G to M. And so it's change in y, so y2 minus y1 over x2, I'm going to change that to a decimal, minus x1. So I get, that's negative 3 over, let's see here, that's negative a half, which would result in 6. So I got the slope of that line is 6, so I figure out this slope. Now I'm just going to write the equation. So I'm going to use my point slope formula. I'm going to pick either one of those points, so I'll pick the point, I don't know, I'll pick G. So I'll use the point negative 2, 7, plug in my slope, and write the equation. All right, so I'm just kind of solving for y here is all I'm doing. All right, that's the equation of my first median. That was fun, right? Now let's do the exact same thing, but let's find another equation of another median. So what I'm going to do is I'm going to median of from point H to GF. So I'm going to find the midpoint of GF. All right, so you add up your x's, divide by 2, add up your y's, divide by 2. So you should get negative a half, comma, looks like negative a half, comma, 6. So negative a half, 1, 2, 3, 4, 5, 6. Oh, negative a half. 1, 2, 3, 4. Yeah, that makes a little more sense. All right, I'm going to call this n. No reason why, just calling it n. All right, so now I'm going to find the equation of this median from h to n. So again, I'm just finding the equation of a line. So this is more back to algebra 1. So I'm going to find the equation of the line h to n. So I'm going to start by finding the slope. So I'm going to do change in y over change in x. So 6 minus 3 over negative a half minus negative 6. So I get 3 over 5.5, which results in 6 over 11. Not the prettiest of numbers, but nonetheless still a number. All right, now we're going to use our point slope formula to figure out our equation. So I'm going to use, I guess I'll use point H. Again, doesn't really matter. All right, and now I'm just going to write my equation. So 6 over 11 plus, all right, what is that? 36 over 11, makes it fun. I'm going to add 3 to both sides, and I'm just going to add 3, which ends up adding 33 over 11. Anyways, I get 69 over 11. And if you don't like that, I'm going to keep it as a fraction just because it's more accurate, and I don't want to have any error in my problems. All right, so what I did now is I found the equation of those medians. And so now, if I wanted to figure out the coordinates of the centroid, I'm basically going to go back to my graph. I'm going to go back to my graph, sorry about that, and I am going to find the point where they intersect. So in order to do that, I'm going to solve the system. So I'm just going to take those two equations, and I'm going to set them equal to each other and solve for x, and then solve for y. All right, so 6x plus 19 is going to equal 6 over 11x plus 69 over 11. Okay, I am going to, let's see here, subtract. So I'm going to make this a common denominator of 11. So I'm going to subtract 6 11s from both sides, so 6 11x, so I get 60 over 11x plus 19 equals 69 over 11. I'm going to subtract 19 from sides. And what is my, if I do that, I get, I subtract 209 over 11. That's what 19 is, if I subtract that. So I get negative 140 over 11. And then I'm going to divide by 60 over 11, or in other words, multiply by 11 over 60, and I get negative 7/3 as my x value. All right, not the prettiest of numbers, but again, just because we have different kinds of numbers doesn't mean that it's any less accurate. All right, now that we know our x value, let's plug it in to find our y value. So go to one of the original equations. I'll probably pick the one that says 6x plus 19 just because it has no decimals or fractions in it. I'm going to plug in -7/3. I'm going to get -14 plus 19, and so I'm going to get y to be 5. So the coordinates of my centroid are at the point -7/3, comma 5. Let's just double check. -7/3 is what? Like -2 1/3? So 1, 2 1/3. Yeah, looks about right. 1, 2, 3, 4, 5. Perfect. So my centroid is -7/3, comma 5. All right, obviously a little bit more challenging of a problem, but I want to remind you that the math here is all stuff that you're able to do. It's just, it's just stuff that you haven't done in a little while necessarily. Okay, I'm going to save some other problems. We'll do some more of that in class, but I'm going to kind of come back to this. All right, let's now go back to our student journal. So we're back to page 178. And let's look at number 9. So now we're going to talk about the orthocenter on the inside, outside of the triangle, and find the coordinates. Okay, so first let's do number 9. This is a little bit easier. And so this one says we're gonna tell the orthocenter is inside or outside, then find the coordinates of the orthocenter. So I'm going to go ahead and draw a 1-quadrant graph. And the reason I'm doing this is because if you notice, all the points are in the first quadrant. So if you can grab a sheet of graph paper, feel free to do so. I'm just going to go ahead and use this. So 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. So this is x, and 11, 0, that's 10, I think it's about right here, is z, and then 3, 0. So notice that, again, just kind of like that example when we did with the centroid, we're going to have one of our line segments are either going to be vertical or horizontal. It just makes your problem a lot easier, as you could tell from the last example we did. So anyway, we have this lovely right triangle. All right, so the orthocenter, what we're getting at here, go back to this. All right, so if you want, you can grab another sheet of paper. So what we're going to do is we're going to find the altitudes of from two different vertices. So we're going to find the altitudes, and then we're going to find the point of intersection. So to do that, what I'm going to do is I'm going to find the slope of the opposite side. I'm going to find the perpendicular slope using the vertex and find the equation. And then I'm going to find the point of intersection. So for this one, it's not quite as challenging, I don't think. So if I wanted to figure out the orthocenter, this one is actually fairly straightforward, because if I wanted from this vertex perpendicular down, well, I already have that line. It's already perpendicular down. If I wanted from this vertex perpendicular to the opposite side, it already is that way. The only one I don't have is this one perpendicular down. But if I had this is one altitude and this is another altitude, my points of intersection here are going to be where that orthocenter is going to meet. So therefore, my orthocenter is going to be at the point 3, 0. So again, that makes it really, really easy on that one because of the fact that I had kind of a right triangle there and not something that was, I don't know, like more challenging on that one. And so we'll get to ones that are a little bit more challenging here in a second, but I just kind of wanted to show you that there are some scenarios in which, obviously that the work is a little bit easier. All right, so inside, outside of the triangle, or on the triangle, here's kind of what I want you to write down for that. And so basically what you notice is if you have a right triangle, so obviously this example we did here is a right triangle, my ortho is going to be on the triangle. So it's not going to be in the triangle or outside, it's going to be on the triangle. If you have an acute triangle, your orthocenter is going to be on the inside of your triangle. And if you have an obtuse triangle, you're going to have it on the outside of the triangle. So just kind of write that on the side there so that you kind of remember that, and then there's a couple examples or questions that are going to come back to that. Okay, let's do a more challenging one to kind of end today. So again, I would encourage you to grab a piece of graph paper. We're just going to kind of do this one as kind of a whole group, so to speak, not one that's on our student journals. All right. So this one, we are finding the coordinates. So just kind of like we did with the last example, we're going to find the coordinates of an orthocenter. Raise that up. So we're going to find coordinates of an orthocenter. So this one's going to be a little bit more challenging only because it's not going to be as straightforward as the last one where it was pretty much done for us, but the process is still going to be the same. So let's go ahead and start by drawing our grid. And so I'm just going to draw a 4-quadrant grid using my straight edge. Okay. I'm going to give you 3 points. I'm going to give you T, U, and V. So T is going to be the point -2, 1, U is going to be the point 2, 1, and V is going to be the point 0, 4. So this one does have a, it's not going to be a right triangle, but you're going to notice that it's going to have like a horizontal or vertical side. All right, so 2, 1, so if we look at U, and then 0, 4, 1, 2, 3, 4. All right, so that's V, and that's 0, 4. All right, so go ahead and draw on your triangle. It's kind of centered right around that y-axis. All right, so now what we're going to do is we're going to find, basically we're going to find 2 altitudes, and then we are going to find where they intersect. So the first one was easy for us, and so I just wanted to point out the fact that if we find the altitude from point V to the opposite side, perpendicular down, that's just going to be this line right here, right? That's going to be our y-axis. Well, to find the equation of this y-axis, so find that altitude, all we know is that altitude has to have an equation of x equals 0, because that goes straight down. That's the equation for the y-axis. It's a vertical line. So we need to find, so we've got one altitude. We need to find the equation of another altitude. So in this case, it doesn't really matter which one you find. I'm going to find the altitude from T perpendicular to VU. All right, so my first step is to find the slope of V to U. So I want to figure out the slope of this line here. And you can do this using rise over run. You can do this by just using the formula. So change in y, 1 minus 4, and then 2 minus 0. So I get negative, multiplied wrong, or subtracted wrong, negative 3 over 2. So why I did this is because I know that I need to find the equation of the line from T perpendicular this way. So now what I want is I want to take the perpendicular slope of V to U, because I don't want this slope. I want the line I want my equation of my line has to be perpendicular to it, right? So I need to take the opposite reciprocal. So now I know that this line that I'm just going to kind of draw in here, the line that I'm drawing in here, this altitude, has to have a slope of 2/3 because it has to be perpendicular to this line. Now I can just find the equation of this line by using my point T and then plugging it into my equation. So my slope is 2/3. And if I do this correctly, I get y minus 1 equals 2/3 x plus 4/3. And I get 2/3 x. If I add 1 to both sides, I get 7/3. All right, so that's the equation of this line. Okay, here was the equation of my other altitude, right? X equals 0. So all I'm really doing here is I'm plugging in x equals 0 into this equation. So 2/3 times 0 plus 7/3, I get y to equal 7/3. So what I understand now is I got an x value of 0, I get a y value of 7/3. So I know that my orthocenter, so that point right there, has the coordinates of 0, 7/3. Oops, off my screen here a little bit. All right, so not quite as, I guess, I don't want to say challenging or tedious as finding the centroid coordinates, but nonetheless, still a little bit more elaborate than just kind of looking at your diagram. All right, so I apologize if these videos are a little bit long, but I did want to go through some more challenging examples. I figured that would be helpful at least to have them on a video for you guys. All right, as always, come to class with questions, and I'll see you guys next time. Bye.